start of our webinar week with the ceramic printing together, which in cooperation of 3D-MODEL and 3D-CERAM. Today, I personally will not be giving the webinar, but it will be my two colleagues. It's going to be Arnaud Roux from 3D-CERAM in Limoges in France, and Phil Binkert, who is co-founder of 3D-MODEL, the partner in Switzerland and Germany for 3D-CERAM ceramic printing. Therefore, I will just hand over the webinar right at first to give you the first introduction to Mr. Phil Binkert.
Good morning, everyone. I hope everyone can hear us and have a good sound quality. We will be starting the presentation of ceramic additive manufacturing. If you have questions that come up, feel free to use the question and answer section to post your questions, and at the end we will get to them. So to start off, as we know, in the additive manufacturing area, there are so many additive manufacturing machines out there, 3D printers, that we come slowly to a point of which machine, which is the correct technology to use for our application in this area. And how do we decide which technology to use? And to get there, we have to decide where to go and which questions. Yeah. And important to know is, what do I want to use this technology for? And the first and foremost question is, do I want to use an additive manufacturing a 3D printer for prototyping, functional prototyping, or manufacturing? For prototyping, functional prototyping, we go through many different iterations. It is not parts that we use for end use parts, parts that we have to print a lot and test and do testing mostly in-house. Or am I looking for a machine for manufacturing parts that withstand the elements, that need the stability that's required for automotive, aerospace, medical area? And the second question is, what material? Today, we have so many options to choose from materials for the additive manufacturing. Before, when I started in this business for over 10 years ago, we didn't have such a choice. We only had a machine that can print maybe one type of plastic. Today, we have machines that print many different plastics, from ABS to nylon to flexible material. We have machines that can print metal, different types of metal, from stainless steel, titanium, and even copper. And what is growing, of course, is many different types of ceramic. And the third question we can ask ourselves is, what kind of build volume do we need? Do we need, very simple, a small build volume or a large? How big are my parts? How many parts do I want to print per year or per week? That is also a very important factor that I need to ask myself. And the final question is, what kind of budget do I have? What am I willing to invest? Am I investing in additive manufacturing as a start, or do I already have experience and want to go to the next level? By the 3D model, we have a huge portfolio of different types of technologies. We have from Markforged, Robos, 3D systems, Form Labs, in this area of prototyping to functional prototyping. And you see that we have alone here many different options. And in the manufacturing area, again, we have certain machines, certain types of machines that can fulfill these areas. And therefore, today we will be talking about ceramic. What can ceramic bring us? What are the advantages in this field? Because ceramic is growing more and more. There was just recently an article on 3D-Drucker.com that the ceramic and additive is growing to the 4.1 billion mark. And therefore, I'm very excited to have Arno Roux a part of this discussion here, and he will be taking over of what over the 3D printing in technical ceramics. So I'm going to hand over the screen to Arno. Arno, are you there? Can you hear me?
Yeah.
Okay.
Can you hear me? Yeah.
Okay. So I'm going to stop my screen, and you can start yours.
Can you give me the right to do that?
You just have to below. You should have the right. Sorry for the
inconvenience, but no, I cannot share my screen.
Cannot share your screen. Okay, then I have the presentation, so I'll just you just tell me when to switch.
Yeah.
Yeah.
Yeah. Thank you, Phil. Thank you very much.
No problem.
Good morning to everybody. Thank you for attending this discussion. Thank you to 3D-MODEL for organizing such event. It's very interesting for us to participate, especially in this very strange situation, sanitary situation in the world. Few words about 3D-CERAM. Next slide, please, Phil. We are a French company based in Limoges. The company was born in 2001, and we are linked to the Technical Research Center in Limoges, IRCER, from where the technology, our technology, SLA technology, so stereolithography with a laser, to print the parts. We developed during 15 years formulation, technical ceramics formulation, and we worked on the complete process, not only printing, but also all the post-process cleaning, debinding, sintering to obtain a fully dense part with the same mechanical properties of conventional methods. We begin to share our know-how, and we begin to sell our equipments 4 years ago now. And 2 years ago, the Sinto group, a Japanese group, invested in the company. So now we are part of a very huge group of 4,000 people, which help us to develop this technology all over the world. And really, we are on a long-term collaboration with Sinto. Next slide, please. I was talking about the process. It's really important to understand that it's it's different steps. The first one is the formulations that we developed it in Limoges here. The machine, okay, but after you have all the post-process of firing, which is capital to obtain a final good parts. Next slide. So the process is the CAD file, okay. Our software will slice the parts and into the machine. You put your STL file. The software will slice it, and the laser will polymerize the parts layer by layer. So you obtain at the end a green part. You have to clean to remove the unpolymerized paste at the end of the printing, and 2 steps of firing: debinding and sintering. Debinding to burn the binder we put initially into the formulation, and sintering to fuse all the grains of ceramics together and obtain a fully dense part. Okay. During sintering, you have this shrinkage of the parts. So shrinkage percentage depends of the material we are printing. But for example, to give you an idea, alumina is 50% shrinkage, zirconia 21% shrinkage. So we all this process, we accompany our customers from the printing to the sintering to be sure that the customers obtain a quality part at the end, okay, and a final useful part. Next slide, please, Phil. Thank you. Okay, just a simple drawing about SLA technology. As you can see, the laser, it's a UV laser, polymerizing the part from the top. And you have blades to spread the layer, each layer, so you can adjust the layer thickness for your parts. And the building platform is going down after each layer printed. Okay. Laser is interesting equipment, and we strongly believe that it's the right solution for AM ceramic because you have very accurate parts, and you can do very fine details also. That's important points about the technology. Next slide, please. Freelink technology is a patent we developed here. With this technology, the main advantage, because we are polymerizing from the top, when you need to create a support, for example, you can see we wanted to print the part, the white part, and the red part is the support. We will print the part on the support, and also in ceramic, the support. But we let a small gap between the part and the support. So after printing, it's really easy to remove and unstick the part from the support. No need to do machining. That's really easier for post-process. And the other advantage of using this Freelink technology is we reuse the support for debinding and sintering to avoid any deformation on the part, because the support will take the same shrinkage as the part. Next slide, please. Okay, we call it 3D mix. It's the formulation we developed, 15 years working hard to develop formulation, to develop standard formulation. It's ceramic powder mixed with photosensitive resin, okay, which reacts with the laser. So we developed standard formulations, standard slurries like alumina, zirconia, but also not only oxide but also nitride. So our customers who has the machine have the possibility to buy these slurries to print the parts. But as we are also ceramist engineers, we propose to the customers to begin with their own ceramic powder. So they keep the same mechanical properties at the final stage. So it means that we develop internally with the ceramic powder of the customer, we make the mixture and we make all the development to obtain a final formulations to 3D print parts. So that's also one service we are proposing. The final windows is just focus on open parameters. It means that our customers on this machine can develop their own recipe and adjust many parameters to obtain the best quality of the parts. And that's an important point also. Next slide, please, Phil. Thank you. Ceramic materials. So at the beginning, we begin with oxides. We begin with alumina and zirconia mainly. But today, all these ceramics are available. Silicore, so it's a formulation dedicated to cores for investment casting, silica-based formulations, but also a mixture of alumina, toughened zirconia, corderite for aerospace, because with a very low CTE, it's a very interesting ceramics. Hydroxyapatite also for the biomedical sector. Oxide was the first developments. Now we developed also nitride, silicon nitride, aluminum nitride. At the moment, carbide is not available, but we are working on a formulation for silicium carbide. Next slide, please. Thank you. Okay, so about the market, technical ceramics is everywhere. Nitride, like aluminum nitride, silicon nitride, the two pictures at the top is mainly used in aerospace business. It's also zirconia, alumina, silicon more in the industry, and HAP, TCP, biomedical is really used in the medical sector for biocompatibility. In terms of aerospace, it's mainly used because it resists to very high temperature and it has an excellent thermal stability at high temperature. For industries, it's more electrical insulation, thermal conductivity also, and hardness. The properties interesting in such sector. Next slide, please, Phil. But it's really broad market. As Phil explained, we have a huge growth coming in the next years. The ceramic AM is on course to reach 4.8 billion in 2030 revenue. So that is according to the Smart Tech analysis, which appears last week. So we can say hopefully that the future for AM ceramic appears bright. Next slide, please, Phil. Okay, that is an interesting slide about the wide range of machines that 3DCERAM is proposing. As you can see that we have a small machine, we call it C100 Easy, with a building platform of 100 millimeter by 100 millimeter. The middle one is historical machine C900 Flex, and the big one is the last one we developed, C36000 Ultimate, with a building platform of 600 by 600 millimeter. Next slide, I have a small focus about the machine. It's really developed for universities and research centers. It's not as expensive as the middle machine, and the objective is really to develop, to play with. It's a very user-friendly machine. You can launch a production in 20 minutes. So the objective is really that the customer can develop new parts, and also industrial manufacturers can be interested in such machine because they will develop the parts, and after they can do easily the scale up with a bigger machine if they want to produce more parts. So the next slide is just an example of several parts we printed on the C100 machine. Z-axis is 150 millimeter. It's important. It means that you can also print eye parts. Next slide is about the C900 Flex. It's a historical machine. We developed first one in 2005, but at the beginning we were only printing parts, doing service printing for our customers. So we have a very good knowledge and very good performance on such machine. We have 3 machines here in Limoges running for production. Okay, we call it Flex because you have flexibility to do experimentation first with a small building platform, 100 by 300 millimeter. But when you have the part ready with the right parameters, you can go on a bigger building platform, 200 by 300 or 300 by 300. So it means that you can also produce parts. That's all for this slide. Phil, thanks. That's the very last machine developed in 3DCERAM. We have one machine here to print big parts or to print lots of parts. That's the main advantage of such a machine. For example, I wanted to show you, I don't know, I cannot share my screen, but I wanted to show you a very big mirror for satellites. We built with a diameter of 500 millimeter. So printing, as I said at the beginning, is running good with this machine. Now we are really working on how to debind and sinter correctly such big parts. Okay. The idea for the customers is, okay, you can print many parts. Small is good, but it's better also if you can print bigger parts. Okay, so that's one advantage of such machine. Next slide, please. So we are talking about mass production. Our objective is not to compete with injection molding or machining or pressing. These conventional methods are very important and useful in the sector. It's just with 3D printing a way to open new markets, open new geometries. So the engineer can think differently how to design the part. The idea is really that you can add functionalities to your part. You can group several parts together to make only one. And with the C3600 Ultimate, we are working on how to calculate a cost per parts. And that's really the needs of our customer. We really feel it, that they are asking, okay, it's good, this machine, you can print many parts, but what would be the cost at the end? So we tested, we made several studies to know and find the return on investment on such a machine, and we sold the first machine to a technical ceramic manufacturer, so it will be able to print a large quantity of parts with very complex design. Next slide, please, Phil. Okay, that's another example of what we could do. This is a very good example for cores for investment casting. It's turbine blades. It's very complex geometry, usually thin and quite high parts. So if you print it vertically, you can print lots of parts. So 3D printing is very adapted technology for such parts, because it's not I would say millions of parts required for the customers, but it's maybe hundreds or thousands parts. Thank you, Phil. Next slide. Okay, a few words about next, what we see in the future. What we developed now 3 years ago is multi-material machines. It was developed in a European project called Cell 3D ITER for fuel cell applications. The idea was to add other materials on ceramic parts. So you can go on the next slide, Phil. This is we developed a tool to depose other materials on ceramics. So it can be 2 different ceramics. It can be ceramic and metal, or ceramic and polymers, for example. So here is just a small video showing the nozzles depositing the other materials. So that was developed on the middle machine, on the C900 machines, 3 years ago now. The new thing is that now this option, this hybrid option, this multi-material option is available on the smaller machine, on the C100. So technical research centers, universities, they can develop many things for example, ceramic and metal in the LTCC, HTCC field. That's very something growing, a growing demand for us. It's important for you to understand that today we do not have the know-how to co-sinter. It's another issue, how to co-sinter ceramic and metal. Our customer who bought this machine, they know how to co-sinter. We don't have this know-how today. Next slide, please. And I think it's the last slide. We are really thinking about, in the next coming years, a complete platform to do printing, but not only printing, also cleaning, standard automatized cleaning step, and debinding and sintering. So that is really the objective in development. We call it 4.0. It's a long-term project that we begin 18 months ago now, because we control today all the process, the complete process, and you have to control all the process from the printing to the sintering to obtain final good parts. So that's something we are going to present probably in 1 or 2 years. But that's the future for us, to propose something, a complete line, automatized line, and we will be able to give, of course, a cost per part to calculate the return on investment. So that's the overview of ceramic additive manufacturing that we have. Of course, we are available with Phil to answer your question. I will be pleased to have questions. You can also contact us directly, Phil and I, to discuss about your project. Here you have all the details. Really do not hesitate. Take a picture of this screen, so you have our email address. And the idea is really to discuss about your project and see if 3D printing and this technology can fulfill what you need.
Thank you very much, Arno. Is it possible to show some parts?
Yes, but I don't know how to share my screen.
Okay.
Because I don't see the. I don't have the right, I think, to share my screen.
Maybe I try this now. You should probably have a. Maybe you have the right now.
Yes, exactly.
Does it work now?
Mm-hmm.
Perfect.
But I want. Yeah. I would like to put my video also, because I have parts in live to show.
Oh, that would be fantastic. You just have to share your camera.
Yeah. In the sorry about that. They say I cannot share my video because this animator stop it. You have to.
No, you're sharing your screen, so you have to stop it. If you go with the mouse,
Okay.
yeah, you just stop and then. Now you can share your video, because I think it would be very interesting for the participants to really see parts live.
You're right, but I have always the same. No, I cannot. I tried, but they say the same message. I cannot open my video because the animator stop it. But,
1 minute. See if I can.
Sorry about that.
See if I can change that for you quickly. No, I can't, unfortunately. So I'm very sorry for this, everyone. But what we can do is we can send everyone pictures of the parts that we wanted to show to everyone. I hope that is okay for everyone. And in the meantime, I also see some questions that came in. So I'll just read them, and Arno and I can answer them together. So first question is, what is the difference between a laser and a DLP system?
Okay. You want me to answer, Phil? Yeah.
Yes, please.
Okay. I don't know who asked this question, but it's very interesting. Two different technologies. They both technologies are working well. It depends really of the needs of the customer. What is willing to print. What I can say is the laser can be simple, because we have with the machine receipt ready to use, so it's a push button. You don't have to adjust the parameters, but you can also with the laser be flexible, because you can adjust many parameters to optimize the quality of the parts. The other advantage I see is really that you can use a big platform with the laser, because the laser, we have 7 different size of platform with the 3 machines. So with the laser, you can easily print on big building platform. What I wanted to say, to add, is on the very big machine, 3600 Ultimate, you don't have 1 laser, but you have 4 lasers to optimize time of printing. Another point important is with the laser, because we are polymerizing by the top, you have this free link possibility, and the support is not linked to the part. You don't need to machine it in terms of post process. So that is a huge advantage in terms of supporting, strategy of supporting. So that what can I say about laser? Okay.
Great, thank you. The second question was also about the free link technology, how that works in a technology point of view. Could you maybe re-explain how that process is again?
Okay, it's you create the support and you just put the parts on the support, and you will print the support and the part in the same time. Because we are polymerizing by the top and gravity is with us, the part will just lay down on the support with a small gap between the support and the part of slurry not polymerized. And because with the paste, the slurry we are using, the part won't move on the support. So it means when we remove all the unpolymerized paste, it's easy to remove the support from the part. And as I said, we will reuse this support for debinding and sintering. So the support is also made of technical ceramics.
Okay, great. This is in regards to the multi-material option for the co-sintering with the multi-material. Can you or your partners that do this already help us to develop ourselves at our university?
So can you repeat the question, Phil? Sorry.
This is in regards to the multi-material, the hybrid machine, yeah. And it's a question about co-sintering or sintering the parts with multi-materials.
Yeah.
If there's if 3DCERAM or a partner of 3DCERAM who is already doing this help a university. to help with the sintering?
We have two different partners who can help on these topics. So, a university in Barcelona, IREC, the one who we are already using the multi-materials printing. They know how to co-sinter ceramic and zirconia and metal. And also our university in Limoges, who did parts with, for example, alumina and tungsten, and they know how to co-sinter. So it could be a project developed with companies, with final customers, a third part project with the final customer, the university, and us. This is also a strategy of 3DCERAM to develop collaboration with universities and technical research centers to develop new things. So that's really something interesting for us. Do not hesitate to contact us if you have such a project in your mind.
I have another question. Are there material certifications available for food and/or drug contact to be FDA compliant?
No, at the moment, no. We developed skull implants in the biomedical field. So we printed during 10 years this implant with the norm ISO 13485 for biomedical device. But it's mainly our customers, people who are buying the machine, who should have these certifications.
Okay, so that would mean it is possible, but through the end customer. Did I understand that correct?
Yeah.
Okay, so the possibility is there. Okay, good. Yeah, now see if there's another question. I just wait maybe a minute just in the meantime. For anyone that is further interested, we can always do a one-on-one conference, video conference. 3DCERAM has also the possibility to, through a one-on-one contact, to also show again, to show parts, and also to show the machines live, how they are printing. So I'm sure 3DCERAM and Arno will welcome the opportunity for a one-on-one. I know during these times it's a little bit difficult to travel. So please feel free to contact me or Arno.
Yeah, we have to adapt with this situation. And so we develop tools to present our technology and machines in live by distance. So we can just ask me, and we organize such a conference.
Yeah, no, great. Then there's no more questions. Again, thank you everyone for participating. Also, thanks again, Arno and from 3DCERAM. And we hope to talk with everyone, everyone will receive also an email. We have this webinar also recorded for those that wish to have the recording. And like I said before, we will be sending a separate email to everyone with photos of the parts that we couldn't show technically. So sorry about that, but we are very, very excited for the future in ceramic. Thank you.
Thank you.